Welcome to The Explainer. Today, we're going to dive into the invisible rules that stop catastrophic accidents from happening in places you and I see every day. And let me tell you, these aren't just suggestions. They are complex codes that literally mean the difference between life and death. Okay, so let's kick things off with a bit of a riddle. Think about an oil refinery, a flour mill, and a paint shop. On the surface, they seem totally disconnected, right? One's about fuel, one's food, the other's for finishing products. But they all share this hidden and very serious danger. What do you think it is? The chilling answer is that they all have the potential to explode. And this isn't some theoretical what-if scenario. No, this is terrifyingly real. We've seen the devastating results, like the Imperial Sugar Factory disaster in 2008, all caused by simple sugar dust, or that massive explosion at a Venezuelan oil refinery back in 2012. So, that brings us to our first section, an explosive question. Next up, the anatomy of an explosion. Or, to put it more simply, why things go boom. So, it all boils down to three things. It's often called the explosion triangle. First, you need a fuel. That could be a flammable gas, a vapor, or even something like fine dust. Second, you need oxygen, which, let's face it, is pretty much always in the air around us. And third, you need an ignition source, a spark or some kind of heat. To get a fire, or worse, an explosion, you absolutely need all three of these things at the same time. Okay, so here's the crucial part. In most of these industrial places, the fuel is part of the job, right? And the oxygen, well, it's everywhere. You can't just get rid of them. That leaves just one thing that we can control, the ignition source. So the entire safety strategy for these hazardous locations revolves around one goal: eliminating or containing anything that could possibly cause a spark or get too hot. But here's where it gets really interesting. An ignition source isn't always what you'd think, like a spark from a switch or an open flame. Nope. It can be something as simple as a really hot surface. See, every flammable material has something called an auto-ignition temperature. It's the point where the substance will just burst into flame all by itself, just from heat, no spark needed. That means even a motor that's overheating or a standard light bulb could be enough to set off a total catastrophe. So how do we manage all of this risk? Well, that brings us to our next part. 2 codes of safety. You can think of these as the global languages that engineers use to prevent disaster. So you've got these 2 major standards, and they actually tackle the problem from different angles. In North America, they mainly use the NEC, the National Electrical Code. Its main question is, what can burn? It's all about the type of fuel. But for most of the rest of the world, they use the IEC standard, and it asks a totally different question. How often is the danger present? Let's dig into that NEC system first. It's actually pretty straightforward. It's broken down into 3 classes based on the fuel type. Class I is for your flammable gases and vapors, like propane or hydrogen. Class 2 is for combustible dusts. And yes, I'm serious. Stuff like flour, sugar, or fine coal dust can be incredibly explosive when it's kicked up into the air. And then Class 3 covers easily ignitable fibers, the kind of stuff you'd find in a textile mill or a woodworking shop. Now, the IEC system, on the other hand, it uses zones. And this is all about how often that explosive atmosphere exists. So, a zone 0 for gas or zone 20 for dust, that means the hazard is there continuously or for long periods. It's basically always a threat. Zone 1, or 21, means that the hazard is likely to be there during normal operations. And Zone 2, or 22, means the danger only really shows up if something goes wrong, like a leak or a system failure. All right, so that's all the theory. But how does this stuff actually work in the real world to keep people safe? Let's get into it. Making industries safe. Let's make this super clear. Just picture a normal gas station pump. The little space right around the nozzle where you know there are going to be some gas vapors while you're fueling up, that's a classic Zone 1 area. The danger is expected. But the area a few feet away, that's considered Zone 2. It only becomes hazardous if something abnormal happens, like a big spill. And here's the kicker. Each of the zones legally requires completely different, specially designed electrical equipment to guarantee you won't get a spark. And that right there brings us to the most critical and, frankly, the most important point of all. You can have the most detailed, brilliant classification systems in the world, but they are absolutely useless if they're not followed to the letter. The single biggest cause of these horrific disasters? It's as simple and as tragic as someone installing or choosing the wrong type of equipment for that specific hazardous area. Ultimately, that's what this is all for. This whole system is a universal language for safety. A classification like Zone 0 or Class I isn't just some random jargon. It is a precise, non-negotiable instruction that tells an engineer exactly which type of explosion-proof motor or intrinsically safe wiring they must use. It's what prevents simple flick of a light switch from igniting a disaster. It really makes you stop and think, doesn't it? These codes for hazardous locations, they're just one example of this huge, invisible architecture of rules and standards that are quietly working in the background every single day to keep our very complex, high-tech world from, well, falling apart. It makes you wonder, what other hidden systems are out there keeping us safe?